So hi all, welcome to the lecture series on solving previous year questions of GATE ECE, and we were solving the questions related to digital electronics. So this is the first questions of today lecture. This is from GATE 2022. The question is consider the 2-bit multiplexer shown in figure. The output to be the XOR of C and D. The values of A0, A1, A2 and A3 are. So the question is like mux is given here, and C and D are the select lines S1 and S0 of the mux, and we have the input A0, A1, A2, A3 connected to 0, 1, 2 and 3 of mux inputs. Okay, and the question is what should be the values of A0 to A3 such that this acts like a XOR gate, right? And what is the input here? C and D should be the input of the XOR, and the output is the output of the mux. Okay, so we'll first write the truth table of mux. So I have C, D and output. Okay, for C 0, 0, 1, C 1, 0 and 1, 1. So these are the inputs, and we know for XOR gate when inputs are 0, 0 and 1, 1, the output is 0, and if there is any difference between C and D, then the output will be 1, right? So from this circuit CD 0, 1, 2, 3 and this output, we know when input is 0, 0, the output should be 0, right? So when input is 0, 0, the mux input corresponding to 0 will be selected. So what should be the input here then? It should be 0. Okay, now when input is 0, 1, then the output is 1. Okay, so we know when the input is 0, 1, the input 1 will be selected, so here it should be 1. Okay, similarly when the input is 1, 0, the output should be 1. Okay, and when the input is 1, 0, the input 2 will be selected, so I have to set here as 1, then only that input will come to the output. Okay, similarly when the input is 1, 1, the output should be 0, and we know when the input is 1, 1, the input corresponding to the pin 3 will be selected, right? So here the input should be 0, so that I will get a output 0 here. So what should be the input corresponding to A0? A0 should be 0, A1 should be 1, A2 should be 1 and A3 should be 0, right? So the answer will be A0 0, A1 1, A2 1, A3 0. Answer is C. Yeah. Now let us come to the second question. This is again from GATE 2022. For the circuit shown, the clock frequency is F0. So I have a clock here, its frequency is F0, and the duty cycle of the clock is 25%, which means I have a clock like this. Okay, if say this is T, this will be T by 4, right? Yeah. Now for this signal at Q, at the Q output of the flip-flop. Okay, so the question is what should be the output Q? Okay, and if you see here in the option it is given like frequency is this much and duty cycle is this much. So among these options we have to select which is the corresponding output Q. Okay, so if you see here this is a 2-bit counter. First one is a 2-bit counter, and the LSB of the 2-bit counter is connected to the input of flip-flop. So what is the output of 2-bit counter? So that is 0 0 0 1 1 0 1 1, where this is the LSB and this corresponds to the MSB. right? And it's a counter, so again it will repeat. So if you see here, if you see the LSB here, first cycle it will be 0, then it will be 1, then it will be 0, 1, 0, 1. So it is actually repeating 1, 0. It is actually, we can say it is toggling, right? So when the clock frequency, so I will draw here. So this is the clock. Right, and we know at the rising edge of this clock, the output of both counter and flip-flop will change, right? So first I will draw the what is the output change of the LSB of the counter. Okay, so for every rising edge this LSB will change, right? So if I draw here, it will be like, initially if it is 0, at this rising edge it will be 1, and at the next rising edge it will go to 0. So it will be like this. Okay, this is the LSB of counter, right? And what happens, so this LSB is actually connected to the input of flip flop, and if you see here, it is a JK is short circuited. Okay, so J and equal to K. Okay, so what happens when J and K is equal to 1, Q will be equal to Q bar, it will toggle. Okay, and when J is equal to K equal to 0, then Q will be same as previous Q, right? So if you see here, so definitely the output of the flip flop will change at the rising edge. Okay, but depending upon it depends upon what is J and K. Okay, so I will draw here. So if initially it was initially 0, at this rising edge, what is the input here? Input here is actually 1 now. Okay, when at the rising edge, when LSB is 1, the output Q will toggle. Okay, it will change to 1 high. Okay, and so it will be high now. Okay, now in the next rising edge here, in the next rising edge, what is the input here? J and K is actually 0, right? Now it will be 0 because LSB is 0. So since it is 0, whatever is the previous in output Q, that will be the next output, right? So it will remain same. So I'll have 1 itself. Now again in the next clock cycle, or next rising edge of the clock cycle, what happens? The LSB has changed to 1 here. Okay, so again the LSB has changed to 1, means J and K is 1. So what happens? The output will toggle, or output will change to 0. Okay, in the again next rising edge, it is again 0, so it will remain same, and it will change to 1 in the next rising edge, because now the LSB is 1. So we'll get somewhat like this. Okay, so this is Q. Okay, and what is the time period of this Q? This is, I will call it as a TQ. Okay, so this will be the time period of the Q. Now if we see here, how many clock cycle we require here? So so that it is repeating, Q is repeating, I require clock cycle 1, 2, 3 and 4. 4 clock cycles. So TQ will be equal to 4 times T, right? Or I will say like 1 by TQ, which is the frequency of output. Okay, I will call it as FQ. That will be equal to 1 by 4T, or so here the frequency of clock is F0, right? So I can write F0 by 4. So this is the frequency of the Q. So I can have either the option A or option B, having F0 by B, F0 by 4. Okay, now the other thing is, what is the duty cycle of Q? So if you see here, both this on time and off time of Q, so T on and T off, right? Both T on and T off are same, equal to TQ by 2. So what is duty cycle? Duty cycle is T on by total time TQ, right? So it will be like 1 by 2 or into 100. So it is like 50% duty cycle. Okay, so the answer is, the duty cycle is 50%. So answer is option E, right? Yeah. Now coming to the next question, third question. It is again from GATE 2022. A state transition diagram with states A, B and C and the transition probabilities P1, P2 etc till P7 is shown in figure. Example, P1 denotes the probability of transition from state A to B. For this transition diagram, select these statements which is or are universally true. Okay, so like the statements, if you see here, it is a relation between the probability of transition. Okay, so if we can first write the probabilities here. So in case of state A, from state A, if you see here, there is a chance that A transitions to B, the next state B, okay, or A remains same at A itself with a probability P7, and A can also transition to the state C with a probability P4. Okay, so A can either remain at A or can transition to B or to C, right? That is only 3 cases. So from that, and with probabilities P1, P7 and P4, right? So from that we know it can either remain at A, B or C, which means that is the net probability. So P1 plus P4 plus P7 is equal to 1, right? It can either be at P1 probability transition from A to B, or with probability P4 it can go to A to C, or it can remain at P7. So net probability is 1, right? So P1 plus P4 plus P7 will be equal to 1. Okay, similarly we can write for B. Okay, so from this transition diagram, B can either remain at B itself with a probability P2, or it can transition to A with probability P3. There is no transition to C according to this state diagram. So from this P2 plus P3 is equal to 1, right? And what about the state C? So state C, if you see here, C can either remain at C itself, or it can jump to A with probability P6 and P5, right? So the net probability P5 plus P6 equal to 1. Okay, now if we see here in the options, this probability is there, like P1 plus P4 plus P7 equal to 1, that is there in this option C. So this is a option which is correct. Okay, we'll see from option A, P2 plus P3. So P2 plus P3 we know this is equal to 1. Okay, this is equal to 1, and P5 plus P6, this is also equal to 1. So these both are equal. P2 plus P3 is same as P5 plus P6. So option A is also correct. Okay, now option B, if you see here, P1 plus P3 equal to P4 plus P6. So here how we can we'll see whether it is correct. So from here I can get P1 as 1 minus P4 plus P7, and from here I can get P3 as 1 minus P2. Okay, so P1 plus P3 is equal to 2 minus P2 plus P4 plus P7, right? And I'll put as equation 1, and here RHS we'll see from this equation. Okay, again from this equation I can write P4 as 1 minus P1 plus P7, and from this equation I can write P6 as 1 minus P5. So on summing this, P4 plus P6 is equal to 2 minus P1 plus P7 plus P5. This is equation 2. From equation 1 and 2 it is clear that both are not equal, so definitely this is not correct. Okay, similarly we can try for P2 plus P5 plus P7 also. So this will also be wrong. Okay, so if we check this relation, that won't be equal to 1. So only the option is A and C, right? Thank you.